different bits of the human brain. We actually really don't know that, and we're still exploring a better understanding of fundamentally, what are the subcortical and cortical structures that really are wired up to those pivotal systems in the brainstem that really are the sort of gatekeepers, if you like, to what is allowed into the cortex. We don't really have that understood. So again, we've got now non-invasive tools that allow us to map your brains and understand better how you're wired up. But more importantly, we have analysis tools that can quantify the integrity. How well are you wired up? How resilient or how vulnerable is your white matter tract between region A and region B? And how does that communication, that wire, how does that potentially alter as you transit from acute to chronic? How is it maybe different in you, right here and now, compared to your neighbour? And how might that confer a vulnerability post some injury to cascade down and set off the wrong networks? We can quantify these, again, with exquisite resolution. And even, again, in the more sort of broader cognitive neuroscience, again, taking you all now, if I did, say, a particular, cognitive task, amazingly, I could actually stratify you just based on how well wired you're up, say, in your attentional system, and how well wired you're up will be predictive of how well you perform, say, in that particular cognitive task. So how these very subtle variations in how you're fundamentally wired up, which we can measure, turn out to be highly predictive of really complicated behavioural performances and measures. And I think a few years ago, the neuroimaging community, we would never have believed it would confer such specificity, but it does, and there's many, many experiments to prove that. We can get spectral data. We can actually look at neurotransmitters, GABA, glutamate, N-acetyl aspartate. We can look at different chemicals that are very relevant for, again, understanding how healthy your brain is, but also how well is it able to release neurotransmitters and communicate. And again, we can get that three-dimensionally across the brain. We can obviously do the task-based functional imaging, which